Hey guys, it's Mr. Sands. Welcome to the inverses. This is your part 1. How do we find an inverse? First, let's start with graphing two equations in our bell ringer. Y-intercept of 2 with a slope of 2. So that's exactly what I'm going to mark off here. We keep the slope of 2 going backwards. Once you get it started to the right, going to the left is pretty quick and easy. Now remember, this was my slope, this is my y-intercept. As far as this one goes, I'll do it in purple. So my intercept is at -1, and I'm going up a half every time. So I go over 2 up 1, over 2 up 1, over 2 up 1, and so on until I'm off my graph. I'm going to go backwards. Okay, quite a bit of points. I'm going to do the best I can to connect those. I think I can do better than that. Let's try that again. Okay, so what you actually graph there, in that graph, these are inverse functions. Now the reason I know that is because if I draw a line at y equals x, that line would look like this. Bent down there a little bit. What I'm doing is I'm basically marching off a slope of 1. This one's easier to see because I'm on my screen here. So if I reflect these, you can see this is a perfect mirror reflection about that line I just dashed. Okay? So you know that they're an inverse relationship. That's how you would look at it graphically. As far as numerically, if you had a t-chart here for, say, this blue function I did in blue, it would be at 0, 2, 1, 4, and then say 2, 6. I do the same thing with my purple function. Same points, right? If I do 0, 1, and 2. First off, 1's not going to be nice, but let's do 0. If I put 0 in here, I get -1. If I put 1 in, I'm going to get -half. And if I put 2 in, I'm going to get 0. Okay? So you can see here, 2, 0, 0, 2, they literally flip around. Okay, so maybe I should try one like 4. Because if I put 4 in, I know I should get 1. So 4, half of 4 is 2, 2 minus 1 is 1. So you can see these two are mirrored up. If I do 6, half of 6 is 3, 3 minus 1 is 2. So you can see it's 2, 6, 6, 2. Right? That's how you would do it with the table. If the x and y values are literally switched here, you have inverses as well. All right, moving right along. There's your charts that I just did. Okay, they did -2, 0, 2, and the other one, they could do that. So, let's come down here. See if I get that just right. All right, it says a teacher had to find the inverse of f of x equals 2x plus 4. We'll read over this example, write what the teacher did to get each step. So, this is the original problem. All they did here was change f of x to y. Right, from here, it looks like all they did was switched the x and y values. At this point, looks like they subtracted 4 from both sides. And then they look like they divided by 2 from both sides. Okay? And the last thing they do is they changed y to f to the -1 of x. Okay, picking up with this definition here, where the asterisk is, yeah, the graph of an inverse function is the reflection of the graph of the original relation. The line of the reflection is y equals to x. To find the inverse of a relation that is given by an equation in x and y, switch the roles in x and y and solve for your y value. So an inverse function, if you do compositions, we do f of g of x, and that equals to x, and g of f of x equals to x. We know that those two functions are inverses of one another. So that sounds really complicated. Let's break it down and make it as simple as we possibly can. Okay? So, just to start out with our practice here, all I'm having you do is actually solving for what the inverse would be of each problem. So remember the first step from up top here, the original line that we had. Basically all we need to do is switch the x and y. So what I have is x equals 3y minus 5. And now we get y by itself. So that means I'm going to add the 5 over first. And then I will follow that up with dividing by 3. So your inverse for this one would be y equals x plus 5 over 3. This is our inverse for number 1. Number 2. Okay. Before I actually do any switching, I see that I can make this 15. So if I can simplify it first, I'm going to do that. Now, I'm going to do like I did in number 1. I'm going to switch my x and my y. And then I'm going to try to get y by itself, which means I'm going to subtract this 15 over. And then I'm going to divide everything by 4. So I'm going to get y equals x minus 15 all over 4. And there's my inverse of the original. Okay. Now, in 3, this is my original. It probably would be best if I actually put this in form of y equals. So in order to do that, okay, I can write this as 3y equals negative 2x plus 1/4. Okay? And then going to make this 1y. So I'm going to multiply by 1/3 both sides. 1/3 times 3 gives me 1y. I'm going to distribute in my 1/3 here, so this is negative 2/3 x plus 1/12. So this is my original. I am now going to go after my inverse of this. So this means, again, I'm going to switch the x and the y. So x equals negative 2/3 y plus 1/12. I'm going to subtract the 1/12 to the left. And now I'm going to make this a positive 1y. To do that, just multiply by the reciprocal. Okay? So this is going to be a positive 1y here, because this is going to make negative 6, or positive 6 over 6, which is 1. Over here, I'm going to get negative 3 over 2x plus, because a negative times a negative, and it'll be 3 over 24. Now I can reduce this, and that's what I'm going to do here. That cannot be reduced, so this would be 1/8. That's what y would be. So this is the original. This is my inverse. All right? Let's take a look at the last 3 here. Okay, so the next 3, 4, 5, and 6. Remember, this is just a fancy way of saying y. Square root of x plus 4 minus 1. Let's go ahead and switch our x and y. So this is the square root of y plus 4 minus 1. We're going to add over the 1. And then going to square both sides. If you do this, I guess I should show that. Okay, so x plus 1 times x plus 1 is x squared plus 1x plus 1x plus 1, which is x squared plus 2x plus 1. And this would equal y plus 4. This square and the square root, these cancel out. I square this side, I get this trinomial. And last but not least, subtract. So your inverse function is x squared plus 2x. Okay, so remember that f of x, this is just a fancy way of saying y equals. What we're actually going to do here is switch our x and y. So I have x equals y over 8 plus 13/8. I am now going to be in the process of getting this y by itself. So this is what I'm going to move first. X minus 13/8 equals y over 8. Now, we want this to be 1y, so we multiply both sides by 8. This will be 8x minus 13 equals y. Okay? Now, just to help you out here, 8 divided by 8 is 1. That's why this is just 13. 8 times x is 8x. And then 8 divided by 8 is 1y. Right? So this is our inverse. Moving along, remember y equals 1/2 x plus 1/2. Switch your x and y. Alright. Okay, so this is y now. I'm going to subtract the 1/2 over, just like I did in the last one. And now I want half y to be regular y, so multiply both sides by 2. So we have 2x minus 1 equals 1y. There's your inverse again. Alright, got 3 more to get through, and that's it. Let's switch our x and y, because we already have them here. We're then at the point of moving over our 12/7. So we subtract that over. And then we're going to get rid of that division by 7 by multiplying it out. So this is 7x minus 12 equals y. Kaput. That's your inverse. Coming over here to b, or number 8 I should say, switch the x and y. So this is x equals 1/2 y minus 9. Let's add that 9 over. That's going to equal 1/2 y. And then I'm going to multiply both sides by 2, because that's the opposite of taking 1/2. So this is 1y. 2x plus 18, and everyone's happy. And of course, we have one where we have to get y by itself to start. So I subtract 2x over, and then I'm going to basically multiply by 1/3 or divide by 3. I prefer saying multiplication by 1/3 rather than dividing by 3 because I already have a fraction here. So I'm going to get negative 2/3 x plus 1/6. Let's go ahead. This is our original function. Okay, so remember, this is my original. I'm going to switch my x and y, and then I'm going to get y by itself. So this will be x minus 1/6 equals negative 2/3 y. I'm going to multiply by my reciprocal. And this is going to give us our inverse of negative 3 over 2x. Plus, you're going to get 3 over 12, which will reduce to the following fraction. So this stays as negative 3 over 2x plus 1/4. This is our inverse. All right, guys, fire away with your questions. See you in class in a little bit. Take care.